Hey guys, welcome again to the Maths Club. If you are just joining us, so welcome. So for some time we've been looking at percentage. In the previous video we talked about things like percentage increase, decrease, depreciation, when there is a percentage profit and all of things like that. In this particular video we'll be looking at simple and compound interest. Let's get started. So what is an interest? If I borrow you money, I borrow you 10,000 naira. More often than not, I'll tell you that, okay, for every year that is my 10,000 naira stays with you, I'm going to be charging let's say a 10% fee on the amount. So interest is paid on money that is saved in a bank or borrowed from a lender. And is often expressed as a percentage of the money saved or borrowed. And the money that is saved or borrowed is called the principal. So if you go back to that my example where I said I borrow you 10,000 naira, that 10,000 naira is the principal. And if I'm charging 10% per annum, that means I'll be charging 10% of the 10,000 naira, which is like 1,000 naira. Also, it also depends if I'm doing simple interest or compound interest. So just leading to what I just said now, there are two types of interest. So I have the simple interest and we have the compound interest. I'll say the difference between both of them very soon. For the simple interest is just a method of calculating the cost of borrowing money or the earnings on an investment over time. Just like we said, it is very simple. The interest is calculated only on the original principal amount throughout the period. So even if I tell you that I want to borrow you 10,000 naira at the percentage of 10 interest rates, and you tell me, oh, you want to borrow that 10,000 naira over 5 years, all you just be paying will be just 10% of the 10,000 every year as the interest. So the first year, 10% of 10,000 is 1,000 naira. So in the first year you pay 1,000 as interest, second year you pay 1,000 as interest, third year you pay 1,000 as interest, fourth year you pay 1,000 as interest, and fifth year you pay 1,000 as interest. So that means at the end of the 5 years, your interest, which is like the extra amount that you'll be paying me back, would just be 5,000. So the total amounts that you'll be paying me in this case will be the original 10,000 naira plus the 5,000 naira interest that's accrued over the 5 years. So this example now, imagine you borrow 5,000 naira from a friend and they are going to charge you an annual interest rate of 10%. It now says let's calculate the simple interest after 3 years. So simple, we know that the principal is 5,000 naira and then the interest rate, which is like the R, is 10%. And then we know that the time T is 3 years. So after the first year, we know that it's just going to, in terms of the interest, right, that will be 10% of 5,000 naira. And 10% of 5,000 naira is 500 naira. So the first year it pays 500 naira. The second year it will also be 10% of that 5,000, which will also be 500 naira. And in the third year it's going to be the same 10% of that 5,000 naira, which is 500 naira. So the total interest is going to pay would be 1,500 naira. Simple and short. But if you look at the case, I had to be doing the same calculation over and again. All we just did in this case was converting this 10% to, let's say, 10 over 100, and then we multiplied it by the principal, and then you can see it duplicated itself 3 times. So if I wanted to break that down, that would be like the rate times, or let's say the principal times the rate, and because the rate is in percentage, I can divide this by 100. I've noticed that I did a multiplication 3 times before I added it, so I could just say that this thing will just do it times the number of years that the borrowing or the investment is going to span for. And this leads us to our simple formula for simple interest. Just take the principal times the rate, convert it to decimal by dividing by 100, and multiply it by the number of years T, and that will give you the same thing. So if I wanted to do that for this particular thing, that will be 5,000 times 10 times 3 all over 100, and this will cancel 2 of these 0. 50 times 10 is 500, 500 times 3 is 1,500. So the same results, but in a more compact way. Let's see if we're correct. Great, so you can see that the amount is 1,500. That leads us to our formula, which we have just proved now. That simple interest is just the principal times the rate times the time divided by 100. Simple and short. P is the principal, R is the rate, and T is the time. Now, if I want to know the total amount payable at the end of the period, that will be the principal, which was the initial investment, plus the simple interest. That's how much you pay at the end of the period. So if we go back to our original example, the A, which is the amount, is the principal plus the simple interest. The principal in this case was 5,000 naira, and then the interest that we calculated was 1,500. So by the time I add both of them together, that will give me 6,500 naira. So at the end of the 3 years, when the person is paying back, it's going to pay back 6,500 naira. So let's look at another example. This example says that a man borrowed X naira at 15% per annum simple interest. He paid back 49,875 after 5 years. Calculate the value of X and then the simple interest. I want you to pause the video and try this out yourself. Welcome back. Let's solve it together. So we know for sure that the principal the person borrowed was X naira, and then the rate was 15%, and then the amount that he paid back, which is the A, total amount is 49,875, and then the T is 5 years. So what can we do with this information? We want to find X and want to find the simple interest. We know that A is equal to principal plus simple interest, right? The principal here is X. The A here is 49,875. And the simple interest formula is PRT over 100. So this is PRT all over 100. Principal here is X multiplied by the R, which is 15, multiplied by the T, which is 5, all over 100. So 15 times 5, that will give you 75. 75 divided by 100, that will give you 0.75. So this is like 49,875 is equal to X plus 0.75X. So 49,875, by the time you add X plus 0.75X, that will give you what? 1.75X. So to find X, just divide both sides by 1.75. Simple and short. 49,875 divided by 1.75, that will give you 28,500. So our X is 28,500, which was the amount that the person initially invested. Or is it invested? Okay, this was the amount the person initially borrowed. So we know the value of X. Then they said we should find the simple interest. So the simple interest is equal to, if you look at this formula for simple interest, this is what I broke, and this is what it became, 0.75x. So I can just say simple interest, which is 0.75x, is equal to 28,500 times 0.75. If I multiply this by 0.75, this gave me 21,375. So the simple interest was 21,375. Simple and short. If you got this, well done. But let's check if our answer is correct first off. Great. So 28,500 and 21,375. That leads us to compound interest. So we've moved from the simple interest, so it's just only the principal and then the rates, and then you multiply by the number of years, to compound interest. So compound interest is like growing your money, magic. But you're not just growing the initial amounts, like that case where we're just dealing with the 10,000 naira, 10% of it, 1,000, 10%. No. In this case, we are growing also the interest it already grew before. So it's not just the original amount, we're also saying the original amount plus the interest that will be carrying over for each year as the principal. If this does not make sense, that's fine. Let's go forward. So it says the key difference between simple interest and compound interest is that compound interest takes into account the interest earned or charged in each compounding period. Let's look at this example to buttress what we've been saying. The compound interest on 500 for 2 years at 6% per annum is, let's solve that together. So for the first year, the principal is 500 naira times the rates is 6%. So let's say times 6, then times the year is 1 all over 100. Let's use the simple interest formula for this one because that is just the first year. So 5 times 100. So 100 to cancel year 1, 100 year 5. 5 times 6 is 13 naira. So in the first year, the interest that he got was 13 naira. So in the second year, our principal will no longer be 500 now. Our principal will now be 500 plus the interest that's already gained in the first year. So that will be 500 plus 30, which is 530. Multiplied by 6, multiplied by the number of year, which is 1 all over 100. So if you do this, 530 times 6 divided by 100, that will give you 31.8. So in the second year, he also gained 31.8 naira. So if you add both them together, that will be 61.8 naira. Simple and short. you can see that I used the formula for simple interest for each of the individual years, just that the principal year was already inclusive of the interest that already grew in the second year. If I was to do for the third year, that would be the principal, which is 500 plus 61.8. That would be the principal for this third year, and so on and so forth. So that is the 61.8. Compound interest is calculated using the formula compound interest, which is equal to the amount minus the principal, and they've given you this formula. There is something I want to show you here. Remember when we're doing percentage in the first video, we said if there is a 6% increase, you know, when we're doing you buy something at something increase, max it up at 20% at a discount of 10%, things like that. I said if it was a 10% increase, that would be 1.1. Same thing too can happen here, because it's compounded. The first year there's a 6% increase, that would be 1. What? Great, 1.06. Second year too, there will be a 6% increase, 1.06 times what is the initial amount? 500. So if you multiply this together, that will be 1.06 times 1.06 times 500. You see that this is giving you 561 naira 0.8, which is like this interest plus the principal. So you can see that the total amount that the person will pay back is 561.8. What did I do here? How do we get this 1.06? Remember our formula then? We said that will be 1 plus the 6 is gotten from the rate, which is R over 100. And if we say that we multiply this 1.06 2 times, because number of years was 2. So that's like saying, I can say squared here, or I can say raised to the power of t. Raised to the power of t. So this year, by the time we now multiply this guy by the principal, that's what we did next. We multiplied it by the principal. So this basically it's the principal times this guy. You know, I could have said 1.06 all squared. So this is the same thing. 1 plus 6 over 100 raised to the power of t, where t is 2 in this case. This is the formula for the total amount that the person will get at the end of the period. You can see that this will give us 561.8. But we wanted to find the compound interest. We'll now say that amount minus what? Minus the principal. So this is p times 1 plus R over 100 raised to the power of t minus p. And this is the formula that they give us in this place. Let's say an example to bring it home. A man invests 15,000 naira for 2 years at compound interest. After 1 year, his money amounts to 15,600, but to find the rate of interest and the interest for the second year. I want you to pause the video and try this out yourself. Welcome back. Let's solve it together. So we know that the principal the person invested was 15,000 naira. We also know that the duration of that investment was 2 years and it was compounded. After 1 year, his amount increases to 15,600. So that means the amount A after the first year was 15,600. We're not able to find the rate. So we'll find the rates, we'll find the rate and we'll find the amount. Okay, not the amount, we'll find the interest at the second year, so I2. So from the compound interest formula, I know that my A is going to be P times 1 plus R over 100 raised to the power of t. And then the amount is 15,600. The principal is 15,000 times 1 plus R over 100. We don't know the R raised to the power of t, which is 1. So if we do this and I divide both sides by 15,000, just to make this 1 plus I over 100 stand alone, 15,000, this would cancel this. 15,600 divided by 15,000, that will give you what? Great. So 1.04 is equal to 1 plus R over 100, because anything raised to the power of 1 is still the same thing, right? So I don't need to say raised to the power of 1. Let's call it like terms. That will be 1.04 minus 1 is equal to R over 100. 1.04 minus 1 is 0.04 equals R over 100. And if I cross multiply all my RB, my R will be 0.04 multiplied by 100. And if you do this multiplication, this will give you 4%. So our R is 4%. If the R is 4%, we're also told to find the interest at the end of the second year. So for the I2, since it's just interest and since it's just only 1 year, I could just use the formula for simple interest too. Even though I'm dealing with compound interest, it's still the same thing. So that would be the principal times the rate times the time all over 100. Principal in this case would not be 15,000. it's not 15,000, it will be the amount at the end of the first year. Remember, we're dealing with compound interest. You have to take note of the interest that has already accrued within that 1 year, the first 1 year. So our principal year will be 15,600. We know that our rate is 4 times the time that we're dealing here is 1. So if I divide this by 100, this will cancel this, and that will be 156 times 4, and that's 624. So the interest at the end of the second year is just 624. I mean, like, if you look at the thing, even though this is the formula for simple interest, you can always just use when it's just 1 year. So if you check our answer, let's see if we're actually correct. Yeah, so you can see 4% and then 624 naira. Well done to us. Next example says that a family borrows 1.2 million to buy a piece of land at 13% per annum compound interest. They repay 290,000 at the end of each year. How much do they still owe at the end of 3 years? Let's solve this one together. So we know that the principal is 1.2 million, which is like 200,000. The rate is 13%. Their repayment is 290,000 per year. And then how much do they still owe at the end of T, which is equal to 3 years? This is actually a very tricky question that I'm not going to just start using the formula for. You have to think about it very well. And for this question, you have to break it down into bits. So for the first year, the amount that are going to really be owing, the total amount inclusive of the interest, will just be P times 1 plus R over 100 raised to the power of T, right? So that would be 1.2 million. Multiply this by 1 plus, the R is 13, so 13 over 100, then raised to the power of 1. So this is like 1.2 million times 1 plus 13 over 100. I should not be doing that, so that would be 1.13. So 1.2 million multiplied by 1.13, that means that at the end of the first year, the amount that they were owing is 1,356,000. So this is the new amount that they're owing. But remember, they said something that they repay 290,000 every year. So you have to less that amount from it. So out of this one, they paid 290,000. So if you subtract 290,000 from this, that will give you 1,066,000. So this is the amount that they owe after the first year, which will now be the principal for the second year. Remember, we're dealing with compound interest here. So for the second year, we'll still use this formula now, but the principal is not going to be 1.2 million. It's going to be this value, which is 1,066,000 times 1 plus 13 over 100 raised to the power of 1. So that is 1,066,000 times 1.13. So if you multiply this by 1.13, this will give you 1,204,588. Oh, sorry, 580, not 588. And remember, they also repay 290,000 at the end of the second year too, because they pay that money every year. So minus 290,000. Let's subtract 290,000 from this. That will give you 914,580. So at the end of the second year, they are owing 914,580. So for the third year, same thing too. I won't put it like this, but I'll just say 914,580. Multiply this by 1.13. What would this give you? This will give you 1,033,475.4. So if I subtract 290,000 from it, that would give me 743,475.4. So at the end of the third year, they are still owing 743,475.4 naira. So you can see that this particular question, not every question that you just carry calculator and you just plug into the formula. You have to read the question and understand what the question is actually asking of you. Let's see if the answer is correct. Great, so 743,475. So they just took the whole number part, which is fine. This is also something new called conversion period. So we assume that the loan or the rate will always be in terms of yearly basis, right? Like the interest rates will accrue yearly. But at times where the interest rate does not accrue yearly, there are times where it accrues, let's say, twice a year or 3 times a year, things like that. So when you're doing the compound interest, you have to take note of that. So for the conversion period is the fixed interval of time at the end of which the interest is calculated and added to the principal at the beginning of the interval. So that's just basically it. It's just that timing. You know, we've been assuming 1 year, but now we are saying that it might not necessarily be 1 year. If no conversion period is specified, the conversion period is taken to be 1 year. So if the rate of interest is R% per annum, you have to take into is it per annum or is it per biannum or something, or per half year or things like that, or per quarter. But if the question gives you per annum and the interest is compounded half yearly, then the rate of interest will be that rate divided by 2 half year. That makes sense. And then if the interest is R% per annum and the interest is compounded quarterly, then the rate of interest to be R divided by 4% per quarter. So you need to just be very careful of these things. That's in lights. Bringing that to the lights, we know that compound interest cannot be calculated from now. Instead of just saying 1 plus R over 100, we're not saying 1 plus R over N, because you know that the compounding period might not always be 1 year. So raised to the power of NT. So that's just a small change, where the N is number of times that interest is compounded per unit. Just think of this. Let's see an example. In this example, it says a special bank account pays compound interest at 6% half yearly to savers. A saver deposits 800,000 naira in this account. How much does this amount to after 1.5 years? I want you to pause the video and try this out yourself. Welcome back. Let's solve it together. So the first thing that you see in this question is that there is a rate that's given, but that rate is 6% half yearly. It's not the rate per annum, is the rate per half year. So let's just convert it to the rate per annum just for ease of computation. So that will be 6 times 2, right, which is 12%. So the rate per annum is 12%. So you should just write it there and say this is 12% per annum. Let them know what you're saying. Then the principal the person is saving is 800,000. It's not saying what is the A after T is equal to 1.5 years. That's fine. Our formula for A is what? P times 1 plus R over 100N raised to the power of NT, where R is the annual rate, which we got here by multiplying the half year rate by 2. Let's now substitute. This is 800,000 multiplied by 1 plus 12 over 100 times 2 raised to the power of 2 times 1.5. So this is 800,000. So by the time you do this will give you 1.06 raised to the power of 3. So I'll just punch everything inside my calculator. So 800,000 multiplied by 1.06 raised to the power of 3. That will give you 952,812.8. But instead of saying 812.8, I'll just say 813. So I'll just say to the nearest whole number. So this is the amount of A after 1.5 years. Let's see if our answer is correct. It's 950,813 naira. Next question says that we should find the amount of 50,000 after 2 years. It is compounded annually, and then the rate of interest being 8% per annum during the first year and 9% per annum during the second year. Also, find the compound interest. Pause the video and try this out yourself. Welcome back. Let's solve it together. For this question, I'm assuming that it was an objective question, so I won't need to stress myself too much. We know the principal is 50,000 and the rate of interest is 8% per annum during the first year. So if I wanted to convert it, that would be 1.08 during the first year times, and then is 9% per annum during the second year. That would be 1.09 times our principal, which is what? 50,000. Simple and short. When I punched it in my calculator, it gave me 58,860 naira. So this is the amount that is payable. So if I wanted to find the interest, I'll just say the amount minus the principal, which is 58,860 minus 50,000 is just 8,860 naira. So that's basically it. Simple and short. It's not every time that you use formula. Sometimes just once you understand the basics behind all these things, use whatever short form you can use, especially when it comes to objective questions. So this is 8,860 and 58,860. Let's see if we're correct. It's 58,860. Although they were meant to show the compound interest, I guess it was omitted. Next example says that suppose that we deposit $1,000 in the bank account offering 3% annual interest compounded monthly. How will our money grow? Pause the video and try this out yourself. Welcome back. Let's solve it together. So our principal in this case is $1,000 and the rate is 3% annually, to be very sure. So then it's compounded monthly. How will our money grow? So we know our A would just be P times 1 plus R over 100N raised to the power of NT. So our P is $1,000 times 1 plus our R is 3, so 3 over 100 times our N, because it's compounded monthly. So that will be, how many months are in a year? That's 12 months, so times 12 raised to the power of 12 times, let's say 1. Since they did not say how will our money grow after maybe 10 years or something, we assume the number of years that they're asking us for is 1. So if I do this, will be 1,000 times, let's break up the bracket, that is 1 plus 3 over 100 times 12. That will give you 1.0025 raised to the power of 12. So if I do this raised to the power of 12, then times 1,000, this give me these dollars, so $1,030 to the nearest whole number. Basically, it's very simple and short. Let's see if our answer is correct. So $1,030. Oh, so they did two decimal places, but if I did 2 decimal places, I will have had 42. That's fine. Where is this compound interest applied? So you could use that in the increase or decrease of population. So if they say questions like the population increased after so yeah, you can use compound interest to solve it. Not just only population of people, but also the growth of bacteria. You can use that, and you can use it for rise or depreciation in the value of an item. I think this is I did some small application of what during the first video, in this second video for compound interest, and what we actually did in that first video was compound interest, an application of compound interest, even though we did not really explicitly state it. But all those 1.1 times 1.3 times 0.9, all those things are just like compound interest in the mathematical sense. Let's see this example for growth of bacteria. It says that the count of a certain breed of bacteria was found to increase at the rate of 2% per hour. Find how much the bacteria increased at the end of 2 hours if the count was initially 600,000. Pause the video and try this yourself. Great, let's solve it together. What do we know? We know that the rate is 2% per hour. We want to find the increase after T is 2 hours if the initial count P was 600,000. So this is hours, that is fine, they're both in the same unit. So the increase, is the increase by how much? So the increase, which is like simple interest, will just be the amount minus the principal. The formula for the amount is P times 1 plus R over 100 raised to the power of T, then minus P. You see, I'm not using 100N because these hours, there is no disparity. So the P here is 600,000 multiplied by 1 plus the R here is 2 over 100 raised to the power of T. T here is 2 hours. So minus P, which is 600,000. This is 600,000 multiplied by 1.02 all squared minus 600,000. So let's punch this into the calculator and see what this first half will give us. This first half gave me 624,240. So minus 600,000. This is just 24,240. So that means the 24,240 new bacteria were formed during that period. So that's basically it about this particular question. Let's see if we're correct. It's 24,240. So with this, we've actually come to the end of percentage. In the next video, we'll be looking at WAEC past questions from the last 10 years. If you found this video useful, like our videos, encourage my ministry, and then if you know someone that this can help, please share the word. See you guys in the next video.